let's talk about a fundamental, almost invisible barrier in machine learning. See, our world is filled with concepts, words, and categories. But the world of algorithms, it really only speaks one language, and that's numbers. So today, we're diving into the universal translator that bridges that massive gap, data encoding. It's literally the key that lets our computers make sense of our world.
So what's the game plan? First, we're going to dig into why machines even need a translator to begin with. Then we'll take a tour of the main techniques. Think of it as opening up the data scientist toolkit. After that, we'll figure out how to pick the right tool for the job, what common traps you absolutely have to avoid, and finally, we'll see how this one little step has a massive impact on the world all around us.
All right, first up, the core problem, and it's a big one. At the very heart of machine learning is this simple but pretty profound challenge. Computers just don't speak human. Let's really unpack what that means.
I mean, you'd think a super powerful AI could understand a simple word like red or New York, right? But it can't, not really. And why is that? Because underneath all that fancy complexity, a machine learning model is just a giant, powerful mathematical equation. It doesn't see the concept of New York. It needs numbers. It doesn't understand ideas. It only understands calculations. So without some kind of numerical stand-in, our words are completely meaningless to it. Okay, so if our models only speak the language of math, how in the world do we talk to them? Well, we need a translator, and that brings us right to our solution, a process called encoding.
So what is encoding? At its core, it's exactly this. It's the process of taking all that categorical data, things like colors, cities, product types, and systematically turning them into numbers. It's a really simple idea, but it is the absolute critical first step that unlocks the power of our algorithms.
But why is this so non-negotiable? Well, just try to imagine running a model without numbers. How could it possibly calculate the distance between red and blue? How could it apply a formula to the word New York? The answer is, it can't. Without encoding, you get no calculations, no learning, and definitely no predictions. But simply, no numbers, no machine learning. It's that fundamental.
All right, so we get the why. Now let's get into the how. It is time to open up the encoder's toolkit and take a look at the most common techniques you'll run into. We're going to start with the two heavyweights. On one side, you have label encoding. The idea here is simple. It's a direct swap. You assign a unique number, like 0, 1, or 2, to each different category. On the other side, one-hot encoding takes a totally different path. It actually creates a brand new column for every single category with just a 1 or a 0 in it. Let's see what that looks like in practice.
So here's label encoding in the wild. We just map red to 0, blue to 1, and green to 2. Super simple, right? But here's the trap. Does this mean that green, which is 2, is somehow greater than blue, which is 1? A simple algorithm might actually think so. By just assigning these numbers, we've accidentally created an order, a hierarchy that doesn't really exist, and that can seriously mislead our model.
Now, one-hot encoding completely solves that problem. See, instead of one column with a fake order, we create a new column for each city. So Delhi is just on or off. Mumbai is on or off. Now, no city is greater than another one. They're all treated as equals. The trade-off, though, and there's always a trade-off, is that if you have a ton of categories, you're going to create a ton of new columns, and that can really slow things down.
But what about when that order is exactly what you want to capture? I mean, think about t-shirt sizes, right? Large is inherently greater than small. For data like this, or maybe survey results like low, medium, and high, ordinal encoding is the perfect tool because it actually preserves that meaningful sequence for the model to use.
Okay, but what happens when you have thousands of unique categories? Think about zip codes or user IDs. One-hot encoding would just be a total memory nightmare. This is where hash encoding becomes an absolute lifesaver. It uses this really clever mathematical trick, a hashing function, to systematically sort all of those categories into a fixed manageable number of columns. It's a brilliant way to handle massive feature sets without, blowing up your computer.
Whew, with all these options, how in the world do you know which one to choose? Okay, let's break it all down with a simple cheat sheet. This cheat sheet really helps simplify the decision. And notice there are two key things to think about: the type of data you have and the type of model you're using. So for data with no real order, like cities, one-hot is usually a safe bet. If your data does have an order, well, ordinal encoding is the way to go. But check out the bottom half. Your model choice matters too. A tree-based model can often handle simple label encoding just fine, but a linear model absolutely needs one-hot to avoid learning those false relationships.
The right tool always depends on the job.
But look, choosing the right tool is only half the battle. Now let's talk about 4 really common mistakes that can just quietly sabotage your model's performance without you even realizing it.
Let's walk through these traps. First, and this one is huge, always split your data into training and testing sets before you encode anything. If you don't, you get something called data leakage, which basically tricks you into thinking your model is way better than it actually is. Second, we've seen this one. Never use simple label encoding for things like city names. It creates that fake order we talked about. Third, be really careful with one-hot encoding when you have thousands of categories. It'll just explode your memory usage. And finally, you have to think ahead. What is your model going to do when it sees a brand new category it's never ever seen before? You need a plan for those unknowns.
So, we've covered the theory, the practice, the pitfalls. Now let's see why it all really matters. Because as it turns out, data encoding is the invisible engine powering technologies you and I use every single day.
Ever wonder how your favorite shopping site seems to know exactly what to recommend next? Yup, that's encoding at work. Every time you click on a brand, a color, or a category, that's being converted into numbers. And that's what allows the recommendation engine to spot patterns and make those sometimes eerily accurate suggestions. But the stakes get way higher in healthcare. Encoding is used to convert critical patient data, symptoms, diagnoses, even genetic markers, into a format that predictive models can actually analyze. This is helping doctors and researchers predict disease risk and even track potential outbreaks on a massive scale. And in finance, encoding is absolutely mission critical. To build a credit scoring model, banks have to translate all this categorical information, like a person's employment type or loan purpose, into numbers. The accuracy of these incredibly important models depends directly on picking the right encoding strategy from the get-go.
And all of this really brings us to the key takeaway. Choosing the right encoding strategy is so much more than just a technical step. It's what ensures your model is actually accurate. It's what prevents it from making weird, false assumptions, and ultimately, it's what makes your entire process faster and more efficient.
Look, understanding encoding means you've learned to speak a fundamental language, the one that connects our human world to the world of machine intelligence. You now hold a key that can unlock the value hidden in all kinds of data. So the real question is, what are you going to build with it?